We see a question similar to this in class. We've got several parallel lines cut by, well, these two parallel lines are cut by this transversal here, and these two top parallel lines are cut by that transversal there. Okay. When we have several parallel lines cut by different transversals, what you want to do is just choose two parallel lines and one transversal. So I'm going to choose that parallel line, that parallel line, and I'm going to cut them with that transversal. Okay. Now if we look at this, if you can visualize extending these lines in all directions, you start to get that picture of just general two parallel lines cut by a transversal that we're used to in class. Alright, and then hopefully you can recognize that this angle of 120, that angle right there, and this angle here of 2x plus y, they are same side interior angles. And our theorem from class tells us that same side interior angles are supplementary. So we'll take those two expressions, 2x plus y plus 120, and set that equal to 180. Okay? Because we know that those two things are supplementary. Now that provides us with an equation that has x and y in it, and if we don't know a particular value for x or y, we can't solve for the other variable. Okay? So maybe looking at the other set of parallel lines, we can learn what x or what y is. So now I'm going to look at this red parallel line, that red parallel line, cut by that transversal. Okay? And again, hopefully you recognize the same relationship we saw in the top two, that angle there and that angle there are same side interior angles. Okay? So we'll take 2x minus y plus 140 is equal to 180 degrees. Okay? Now that we have those two equations, again, we haven't solved for x or solved for y, but what's nice is that we have two variables in this equation, we have two variables in this equation. In order to solve for one of those variables, now we have to set up a system of equations. Okay? So I'm going to erase this picture and I'll rewrite these equations in a little bit more beneficial form. If those are the two equations we want, when we solve a system of equations, we want all our x's and y's to be by themselves on the left hand side of the equation, and then all other numbers on the right hand side of the equation. Okay? So right now 2x and y are already on the left hand side, so we're going to write 2x plus y. Okay? Now I want to get this 120 to the other side, so I'll subtract 120 here, subtract 120 here, so it's going to give me 60 on the right hand side. So yeah, 2x plus y is equal to 60. And we'll do the same thing for this bottom equation. Okay, the 2x and the y are already on the left, so I'll leave them as 2x minus y already on the left hand side. Now I want to move the 140 to the right hand side, so I'll subtract 140 here, so I've got to subtract 140 on the right. So that's going to leave me with 180 minus 140 is 40 degrees. Okay, now my goal, once I set this, is called a system of equations. Now you might not be able to see me writing this up here, but I'm just writing system of equations. Okay, that's something we use quite a bit in geometry. It's because we have two variables and two equations. We want to solve for one of those variables. How we're going to solve this is through the process of elimination. We want to be able to add straight down so that either our x's disappear or our y's disappear. Okay. So what we're going to need is, you can choose whichever one you want to eliminate, the x's or the y's. But it's nice to look and say, okay, that's a 1y. That's a negative 1y. Because the signs are opposite and the coefficients are the same, those two things are called additive inverses, which means they're going to add up to 0. Okay? So I don't have to change the equations at all. I can just add straight down now. So 2x plus 2x is 4x. The 1y plus a negative 1y is going to go away. Those things are going to go to 0. So I get rid of them. Okay? And then I get 60 plus 40 is 100. Okay, so now I can 4x is equal to 100. Well, that's easy. Divide both sides by 4, and x is 25. Okay. Now once I know x is 25, I can come back up to one of these equations up here, and I'll go back up into that first one, which was 2x plus y. And this was 2x plus y. This was 2x minus y. once I know x is 25, I can replace that into that equation and go ahead and solve for y then. So doing that, we have 2x is 25 plus y is equal to 60. So it's going to be 50 plus y is equal to 60. Subtract 50 from both sides. So y then is 10. Okay. So x was 25, y is 10, and that's our final answer. And we'll go back to the original picture. Where we had 120 degrees up here, 2x plus y down here, 2x minus y there, and 140 here. Okay, and we just found x to be 25, y to be 10. I'm just going to go back and just check my work. If I know that's the case, that x is 25 and y is 10, if I plug that in, 2 times 25 is 20, or sorry, 2 times 25 is 50, plus y is 60. And now you recognize 120 plus 60, that gives you a total of 180 degrees. And that's what we knew from those same side interior angles. So the fact that x and y are 25 and 10, I now know that those are true statements because of what these angles are showing me. Come down here, 2x minus y, well 2x is 50 minus y of 10. That's going to give this angle to be 40 degrees. And now if I add those two together, 40 plus 140, 180 degrees. So I verified through just direct substitution, and then knowing that same side interior angle should be supplementary, I can check my work and now know that those are the correct answers.